Guten Abend, ich heiße Mariya, ich bin Analytikerin im Yandex. I must confess that that's everything I remember from my German course, so I have to switch to English to continue my presentation. As Jan already said, I'll tell you how to calculate complex metrics using ClickHouse. And first of all, I'd like to tell you a little bit about analysts at Yandex. Maybe, are there any analysts here? Or data scientists? Oh, one, okay. So then, let me just explain what analysts usually do. It may sound a little bit surprising to you, but analysts at Yandex usually can code, and we write a lot of code, actually. Our preferable languages are Python and R. And the main goal of analysts at Yandex is to help our managers to make right decisions. For that, we make different reports, monitors, do research, some visualization, and so on. I believe that the most popular instrument among Yandex analysts is ClickHouse. And here are the reasons why. Alex already told that ClickHouse is a column-oriented database, and it has SQL-like language. Almost all analysts already know SQL or can learn it in a couple of days. And in my opinion, the coolest ClickHouse feature is that it's extremely fast. So you even don't need to go for a cup of coffee every time you execute your SQL query. You get your result just immediately. And one more thing is that ClickHouse allows you to calculate rather complex metrics, for example, as Konstantin already showed you. So today I'll also tell you about it. And tell you the story of one of my tasks to calculate marketing funnels. In Yandex, there is a server called AppMetrica, and it's a free real-time solution for mobile app analytics. So any app owner can configure app to send custom events to AppMetrica and then analyze them in interface. More than that, owner can load the whole raw data using logs API functionality. And as I said earlier, AppMetrica has a rich interface with a lot of useful graphs, but our customers always want something more analytics, and that's why one day one of our clients came to us and asked to calculate marketing funnels. And before adding it to our main product, we decided to make a prototype, and I was the one in charge for it. That's why I'm telling it to you today. So before going straight forward to calculation, let me remind you what conversion and marketing funnels are. No surprise that usually app owners want their customers to take certain actions, for example, to purchase something or to subscribe, to fill out form, usually just to pay money. And this is known as a conversion, but actually user usually needs to go through some set of steps to reach the main goal, and this set of steps is known as a marketing funnel. Here is an example of marketing funnel for common e-commerce app. So first of all, user comes to the catalog, select the best product ever, then look at its characteristics, add this product to cart, and make a purchase. It's theory. In practice, user sequence usually look like this, so there can be some preceding events or other events in between, but we still consider such a user converted because he went through all key steps. And the main metric we will be calculating is conversion rate. And conversion rate is the ratio of converted users to total users. So we need just to determine the number of users that achieved each of our funnel steps. So now we know what we will be calculating, and we can do it. Let's firstly look at the data we will be working with. So we have a device identifier and events, their names and timestamps. So let's start with a pretty easy task and calculate funnel of just 3 events. It's catalog, product, and purchase. And at first I decided to use straightforward approach. Maybe you have any ideas? What is the easiest way to calculate marketing funnels? Alex knows. No doubt Alex is right. There is sequence match function in ClickHouse, and it was developed specifically to calculate funnels. And it's an aggregate function. It gathers all event sequences into array and matches them to a pattern. And in case it matches, it returns 1, and otherwise 0. So let's look at implementation. You know, it's simple query comparing to the one Konstantin showed us. So at first, let's just group our initial rows by device and try to determine whether this user achieved each of the steps or not. For the first step, it's pretty easy. We just need to understand whether the user has event with the name catalog or not. For the second step, we need to use sequence match function, and the first argument here is pattern. Pattern is something like a regular expression, but to the event sequences, and this one just tells that there should be the first event that matches conditions that event name equals to catalog, then any other events in between, and the second event that matches conditions that name equals to product. And similar query for the third step. We just added one more event to our pattern and one more condition. As a result, we get such a table where for each device we determine whether this device achieved each of the steps or not. So to get final result, we just need to sum everything up, and we have number of devices that achieved each of our steps. So what do you think? Is it our happy ending? Of course not, because if it was so simple, there wouldn't be any presentation about it. Let's try to add one more step to our funnel. And if we do this, we will face exceptions that says that pattern proves too difficult, exceeding max iteration. That means that such approach unfortunately doesn't work for us, and we need to think further. Before looking at alternatives, let me just give you a quick overview of arrays functionality in ClickHouse. I believe that arrays is the most powerful functionality ever, and that's why this Go is on this slide. And there are three main features. The first one is groupArray that allows you to create arrays from rows. There also is opposite function called arrayJoin, and the coolest ones are higher order functions. Let's look at some examples. First of all, let's try to create arrays of event names and event timestamps from our initial table. For that, we need to group our rows by device ID and use groupArray function. At the end, we will get a list of event names and timestamp for each device. The opposite function, as I said, is arrayJoin, and it allows us to split arrays into rows. For example, let's consider that for some events we may have a list of purchased products, and here is one event where a user bought a coffee and a cookie. And if we use arrayJoin function on this array, we will, instead of just one event, get two rows with products, so the one row for coffee and one row for cookie. But there could be cases when you have corresponding arrays, for example, a list of product names and product prices. And if you again use arrayJoin, you for sure won't get what you need, because you will get a Cartesian product, and it's just not what we want. And the right way here will be to use arrayJoin section. And if we passed our corresponding arrays to arrayJoin section, we will get again just two rows with corresponding product names and prices. And my favorite functionality is higher order functions. There are a lot of them in ClickHouse, but the most useful ones, as for me, is arrayMap and arrayFilter. And of course, to use higher order functions, you need to define lambdas. In ClickHouse, you could use arrow operator for it. And on the left side, you should specify one or several parameters. And on the right side, final expression. And again, let's look at example. As usual, we create array of event names, and also we will create array of event indexes. You could notice that in ClickHouse and in SQL, indexes start from 1, not 0. And let's try for first just filter out all event names with name catalog. It's pretty easy. We just specify lambda and filter out events with the name catalog. And we will get array without catalog events. And for the second example, let's filter first element of array. For that, we need to pass 2 parameters to arrayFilter and filter by the second one by index. And here we again have array without the first element. So now we learned a lot about array functionality, and we can proceed further. As a quick reminder, we try to use straightforward approach with sequence match, and it doesn't work for us. So let's think, can we make sequence processing just easier somehow? Let's look at these 2 event sequences. For marketing funnel calculations, they are just the same. So no doubt the right one is much easier to process for processor, and we can just replace the same event sequences with one event, and we will maybe have a less difficult query for our processing. Let's do this again with ClickHouse. On our straightforward approach, we use sequence match function over our initial table, and now we need to create a subquery that will, instead of initial query, will return us deduplicated events. And arrays will help us for it. As usual, let's create a list of events, names, and timestamp for each user, and also indexes, and create 2 more arrays with deduplicated event names and timestamps. We need to remain only first events in the list and events with different names from the previous one. So it's really easy, just 2 conditions in our arrayFilter function, and we will have 2 arrays with deduplicated events. To have the same structure as our initial table, we need to pass them to arrayJoin section, and we can use this subquery with our sequence match function. And it's working array, but unfortunately it's working only for 4-step funnel. If we continue to add steps, we will again have the same exception. And the root cause is that calculation difficulty grows exponentially when we add steps because of this point with a star that is sequence of any events, and because one of product requirements was to have up to 10-step funnels. This approach doesn't work for us because we hit limit too quickly. So at that point, I decided to try not to use sequence match and do everything from scratch. And let's just think for a moment, what do we actually need? We need user to have at least 1 catalog event and at least 1 product event to achieve the second step. And also we need that the time of first catalog event should be less or equal to the time of the last product event. So using such approach, we can make up a new algorithm. And let's look at each step by step. For the first step, we just need to find the first catalog event and then to move to the second step. On the second step, we need to find the first product event that happened after the step 1. And the same for the third step, where we need to find the first purchase event that happened after product event. Let's look at example. Again, here is a sequence of user events. Let's find the first step. It's here. Then the second step that follows the first one, the third step, and the last. To implement it in ClickHouse, we again need to use arrays. And as usual, group everything by device ID and create arrays of names and timestamps. And let's look at the first time. First of all, we need to calculate the time of the very first step. For that, we need to take array of event times and get the first time that with name equal to product. The important point here is that we should order our initial table by timestamp to work with correct event sequences. And one more thing you need to remember is that in case this user doesn't have event with the name product, this corresponding step time will be equal to 0. So now let's proceed to the second time. And here we have a little bit more conditions. First of all, we need to get only events with name equal to God. Then we need time to be greater or equal to the first step time. And the last condition is that step time 1 shouldn't be equal to 0, because in case it equals to 0, that means that first step wasn't achieved by this user. And again, we take the very first time when step 2 was achieved, and we move to the third step. And here conditions are pretty the same. We need to take event with the name equal to purchase with the time greater or equal to the second step time, and requires that the step 2 also was achieved. And to get final results, we just need to count cases where each step time isn't equal to 0. And here we have, again, number of devices that achieved each of our funnel steps. And such approach really does work. And the reason why here we have a linear growth, linear difficulty growth, and I need to point out that we were able to have better performances to sequence match because we have a very special case. If we had a case like pattern like here on the screen with just 2 first events, our linear algorithm just won't work for us. So let me show you what we had at the end. We make a Docker container with web application where user can specify dates, some other filters like country and platform, and one or several events for each step. And look at such illustrative funnel chart with all numbers calculated. For our project, we use Docker container, and if you are interested, you could find it on our Docker Hub. Of course, we use ClickHouse for processing and storing data, and some other technologies like Python, Flask, and Plotly. So, wrapping it up, today we looked how calculate complex metrics using ClickHouse and learned a lot about arrays. I believe that you won't give up in case you face any calculation difficulties and try to invent new approaches and think different. And please remember that you can make ClickHouse better even if you don't know C++. Like me, please just use it. And in case you have any ideas how to improve it, please share with us. So thank you. If you have any questions, I will be glad to answer.
Thank you very much.
Thank you. Maybe we shall have a...
Yeah. So that would conclude our formal part of the meetup. Please join us at the reception. And thank you, Mariya, for being our last speaker. I know that's the hardest.